Okay, 211, number 3. This is page 211, number 3. This one, I think I can factor. This factors to x minus 2 and x plus 2. That's a pretty easy one to factor. This one has an x squared in it, and if I take the x squared out, I will have x squared minus 1 left, and that factors to x plus 1 and x minus 1. So it's best to get it factored to start off so we have it. Why is this doing crazy stuff? Okay. All right. So now, are there any holes? There's no factors that match. So then we go to vertical asymptotes. And so there's going to be one at 0 because of the x squared, and it's a double, so it goes opposite direction, or the same direction there, because that's a double, so they're going to both either go up, or both the asymptotes are going to go up. The equation's going to go up by this asymptote, either both up or both down. At this asymptote, x equal minus 1, they're going to go opposite direction. And at this one, at x equal 1, it's going to go opposite direction because they're single, not an even multiplicity. Okay. So just starting our graph here, we have asymptotes at 0, asymptote at 0, at 1, and at minus 1. Okay? And x-intercepts. So that's whatever makes the numerator 0, and that'll be a plus 2 or a minus 2. So 2, 0, and negative 2, 0. Y-intercept. That's whatever makes whatever I get when I put in 0 for x. Well, I can't put in 0 for x because that's an asymptote, so there's none. And the horizontal asymptote, and it is horizontal, it's not oblique, because the degree of the numerator is less than the denominator. This is degree 2, this is degree 4, and when the degree is greater in the denominator, the horizontal asymptote is y equals 0. So it's this line right there, the x-axis. And so now, let's put some of this information on there. I've got the asymptotes on. I got an x-intercept at 2, 0. I have one at minus 2, 0. And I know that it goes in the same direction at this asymptote and opposite here. So, what does this have to look like? Well, it gets closer and closer to 0 as we get way far out here. Has to cross here, but I don't know whether it's crossing from this and then going up, or getting close to this and then going down. So I need to do a little research here. So let's put in negative 1.5, and I'm just going to look at the signs. Negative 1.5, in here, negative 1.5 minus 2, that would be negative. Negative 1.5 in here, this would be positive. Negative 1.5 in here, that factor would be negative. Negative 1.5 minus 1 would be negative. And negative 1.5 squared would be positive. So I get a negative numerator and a positive denominator, which means the fraction's negative here. So it must be headed down there, come up, and then get closer and closer to this horizontal asymptote of y equals 0. It goes opposite, so it must start up here and then it does not cross in here, so it must turn and go back, and it goes in the same direction here, so it must come from here and turn, doesn't cross in here, must go back, and then on this side it has to go opposite, so it must come from here, cross, and then come down towards the axis. Let's check. So go to my calculator, and I have it in number 1, enter, and we're going to graph, and we saw it go down. Oh, I got something else graphing here. Let's turn that off. Graph. So it does this and this. You can't see that it's above the deal coming down through. We can zoom in on it, but we don't see these parts up there. They're up there higher. So we're going to go window and look higher. Let's go 30 for the highest Y. So there it goes down, comes down, down, and there. Now let's look closer there. So I'm going to go zoom in, which is number 2. I'm going to zoom in right here just to verify that it does come up, goes over the top, and then comes down. Let's go zoom in again. Goes up, over, crosses at 2, and then comes down close. And I could do the same thing over there and see that. Okay. Number 4. So we need the factor, so I'm going to go to y equals, turn that one off, and this is the numerator of number 4. So I'm going to turn it on, and then I'm going to go zoom 6, and let's see what it factors to. 0, 1, and 1, 2, 3, 4, 5 twice. 0 says x could have been factored out of this, and I see an x in all of them, so x as a factor. 1 means x minus 1 is a factor, and the bounce at 5 says x minus 5 is a double factor. And this now will factor the denominator. Graph, and I see it bounces at 0, crosses at 1, and at 1, 2, 3, 4, 5. So it has x minus 5 as a factor, x minus 1 as a factor, and x squared. And so I could have pulled out an x squared because it bounced at 0. That could have been there. So that's what this is. This is similar to one of the x's would cancel, the x plus 1's cancel, and one of the x plus 5's cancel. So I would have x minus 5 over x. All right. So, holes. Well, we've got one at 0, but there's an extra factor there of x, and so that says it can't be there. There's an asymptote at x. So that one doesn't have a hole, but at 1 there's a hole. And if I put 1 in, I get minus 4 over 1, which is minus 4. 1 minus 5 is negative 4 over 1, negative 4. And so now we have vertical asymptotes. Oh, we have a hole at 5, it looks like. But then, yeah, but it's also an extra factor. It looks like we might have a hole at 5 because we can't put in 5. And if we put it in here, we get 0 over 5, which is 0. So there's a hole at 5, 0. Okay? Vertical asymptotes. We have a 1 at 0, x equals 0, and That's a hole, and this one doesn't have what, so looks like that's the only vertical asymptote. Excuse me. And x-intercepts, that's when the numerator's equal to 0, not counting holes, so that would be at 0, but that's an asymptote. And at 5, but that's a hole. So it doesn't look like there's any x-intercepts. And y-intercept, that's when x is 0, so that would be 0 over, oh, I can't have any because I can't put 0 in for x because I get division by 0, so there's none. So how about the horizontal or oblique? Well, since it's the same degree, then it's the ratio of the leading coefficients, which is 1 to 1, or y equals 1. So, sketch. This one I'm a little unsure of because of this, so I'm going to check with the calculator, but I believe there's a hole at 1, negative 4. 1, 2, 3, 4. I believe there's a hole at 5, 0. 1, 2, 3, 4, 5, 0. It's also, let's see, and there's an asymptote at 0. It's a double, so the behavior goes in the same direction on either side of it, and it approaches y equals 1 in the, as x gets really large or really small. So it appears it's going something like this, asymptotic to this, hits this hole, then hits that hole, and goes like this. And so therefore it's going same direction, so it must go, let's see, if it's same direction, it'd have to cross over here. Oh, but one of these x's will a hole, so it only counts for one of them. One of them gets canceled, so this is only a single, so it goes opposite direction. My mistake, so it goes this way. If it went this way, it would have to cross, and there was no x-intercept, so I knew there was something wrong there. So I think it goes like this. Let's see if I'm even close. So I'm going to go turn that one off and turn that one on, which is the equation, and let's hope I am sort of right. There's the one going up, and there's the one going this way, and we think there's a hole at 1, so let's check that. Second, calculate the value at 1, and it says there's no value, so there is a hole there. And at 5, second, calculate the value at 5, and it says no value there. Okay. And finally, number 5. So, back to the calculator, we need to factor these. And I've typed this one in down here. Here's the numerator. So I'm going to turn it on and graph it. Nope, I think I saw a mistake. Enter. Graph. Y equal, stop, enter. Yeah, I don't have subtract 6, I got minus 6. I need to make that subtract. Okay, now graph. Looks like it goes through 1, 2, and 3. So the factors of this must be x minus 1, x minus 2, and x minus 3. Just by graphing that, and there's 3 factors, and I got them all, so there's no leftover ones. A lot of what we did last section is really important to this one. Now let's go turn on the other one. Turn that one off and turn the denominator on and graph it. And it goes through 2, 3, and 4. So it's x minus 2, x minus 3, and x minus 4. So there's a match here, so that's a hole at 3 something, and there's a match here, and so there's a hole at 2 something, and what's left is x minus 1 over x minus 4. That's what this is sort of like, except with the holes in it. And so if I put 3 in here, I get 3 minus 1, which is 2 over 3 minus 4, which is negative 2. No, negative 1. So it's 3, negative 2. If I put 2 in, I get 1 over negative 2. So there's the holes. Vertical asymptotes. Well, looks like there's only one at x equal 4. And it's a single factor, so it goes opposite directions at it. Now let's check the x-intercepts. That's whatever makes the numerator equal to 0, excluding the whole, so that would be at 1, and x-intercepts are always 0. So there's only one x-intercept. There's a y-intercept. When we put 0 in for x, we get negative 6 over negative 24, which is 1/4, positive 1/4. And the horizontal asymptote, the degrees are the same, so it's going to be y equal ratio of the leading coefficients, 1 to 1, which is 1. So the sketch, it has a hole at 1, 2, 3, negative 2. It has a hole at 2, negative 1/2. Has a vertical asymptote at 4, and it goes opposite directions at it. Has an x-intercept at 1 and a y-intercept at 1/4, and a horizontal asymptote of y equal 1. So it looks like it goes, hits there, has a hole there, has a hole there, and continues down. And since it goes opposite, it must be up here and go this way. Let's check. And so y equals, come down and turn this one on and this one off, and graph. So it looks like it has a vertical asymptote at 4 and has a hole at 2 and 3. Second, calculate the value at 2, no y value. And second, calculate the value at 3, no value. Every place else there'd be value. Like at 1, second, calculate the value at 1. It says it's 0. And second, calculate the value at 0. And we said that was 1/4, and it's giving me 1/4. It's not even giving me 0.25. Okay, that's those.